Imagine a factory floor where robots gracefully dance around each other, seamlessly completing tasks without a single collision. Sounds like science fiction, right? But Google's DeepMind has turned this vision into reality with RoboBallet, an AI system that choreographs manufacturing robots with unprecedented efficiency. We're surrounded by products crafted by robotic arms, devices with incredible precision, moving in perfect harmony along assembly lines. Yet, programming these intricate movements is a painstaking process, often taking hundreds if not thousands of hours. Enter RoboBallet, a revolutionary AI that empowers robots to figure out their own tasks, eliminating the need for manual programming. But here's where it gets controversial. Can an AI truly outsmart human engineers in orchestrating complex manufacturing processes? RoboBallet tackles a problem akin to the infamous traveling salesman dilemma, but on a much grander scale. It doesn't just optimize routes. It simultaneously solves task allocation, scheduling, and motion planning, a trifecta of computational challenges. As Matthew Lai, a research engineer at Google DeepMind, explains, solving all three of these problems combined is what we tackled in our work. To test RoboBallet, the team created simulated work cells, where up to 8 robotic arms performed 40 tasks on an aluminum structure. Each task required precision, positioning the arm's end effector within 2.5 centimeters of the target, approaching from the correct angle, and pausing to simulate work. And to make it even trickier, they added random obstacles for the robots to navigate. And this is the part most people miss. The system doesn't just avoid collisions, it optimizes the entire workflow in real time, scaling efficiently even as complexity increases. The secret sauce? Graph neural networks. By representing robots, tasks, and obstacles as nodes and their relationships as edges, RoboBallet simplifies the problem. This allows it to compute optimal trajectories in seconds, even in complex, unseen environments. But is this the future of manufacturing, or just a high-tech experiment? RoboBallet isn't just about speed, it's about flexibility. Engineers can experiment with different Nobot layouts and task assignments in real time, seeing immediate results. It can even adapt on the fly if a robot malfunctions, redistributing tasks to keep production running smoothly. However, challenges remain. The system currently works with simplified cuboid obstacles and identical robots, which may not reflect real-world diversity. Lai admits real-world applications would require additional research and engineering. So, what do you think? Is RoboBallet the next big leap in manufacturing? Or is it too good to be true? Will AI-driven systems like this replace human engineers, or simply augment their capabilities? Let's debate in the comments.